Here is a slide that I put together for Chapter 34 review. I am the white, pink, yellow, blue, brown, black text reader. Chapter 34, Electric Current. Introduction. Electric current is the flow of electrons that occurs when there is a voltage across the ends of an electric conductor. The flow continues as long as there is a voltage. Dry cells, wet cells, and electric generators. I should back up. I didn't talk about dry cells and wet cells. So a dry cell is a battery, the little round one that you put in a flashlight, and wet cell is a battery like in the car. Did you know that if you open up the car battery, it's all a bunch of water and other chemicals inside? So that's why they're called wet. And dry cells, batteries, well, they just have dry powder in there. So dry batteries, wet batteries, and electric generators are voltage sources that maintain a voltage across a circuit. The amount of current that flows in a circuit depends on the voltage and the resistance. An increased temperature or a longer wire increases resistance of that wire. A thicker wire decreases resistance. Ohm's law states that the amount of current is directly proportional to the voltage and inversely proportional to the resistance. And there's the equation. Current equals voltage divided by resistance. Resistors are used in many electric devices to control current. We'll talk a lot about resistors later this week. Electric shock is the result of an electric current passing through the body when there is a voltage difference between the two parts of the body. DC and AC, don't worry about. Batteries produce direct current, DC, okay, and power companies make AC, okay. AC is used all over the world because transmission costs are cheap. It's very cheap to send AC and AC electricity from one area to another. It's hard to do that with DC. Skip that. Skip that. Power is the rate at which electrical energy is converted into a useful form of energy. Power equals current times voltage. Current times voltage. The end.